Welcome to the Deep Dive, where we take your sources and unearth the most fascinating insights. Today, we're plunging into, well, one of humanity's most talked about achievements, the Apollo 11 moon landing. You sent us some incredible material, from detailed mission accounts to those persistent questions that have swirled around it for decades. Our mission: to unpack the dramatic, almost unbelievable story of how two humans landed on the moon, the near disasters they faced, and then tackle the common theories head-on. But we're also going to dig into the surprising and often overlooked critiques of the mission and its lasting, unexpected impacts.
Yeah, what's truly remarkable about this event, as your sources detail, is how it started as this fierce global competition and then transformed into a crucible for technological innovation. It really shifted public perception in profound ways, both positive and negative. We're going to try and connect those pretty complex dots for you today.
So let's journey back in time and uncover the incredible story behind the moon landing. Now, many think it was purely about scientific discovery, right? But your sources reveal a much more complex and, frankly, more dramatic origin story. It began right in the heart of the Cold War.
That's precisely where your sources pull back the curtain. The context, as you said, was this fierce space race between America and the Soviet Union. And the Soviets had undeniably taken an early commanding lead, no question about it.
And it wasn't just a small lead, was it? Imagine the sheer shock, the unease across America when, back in 1957, the Soviet Union launched Sputnik, the first artificial satellite, the first man-made object ever to orbit Earth.
A huge psychological blow.
Right. Then, just 3 years later, 1961, another massive hit. Soviet cosmonaut Yuri Gagarin becomes the first person in space. It was just this clear demonstration of Soviet technological prowess.
So the critical question for the United States became, how do we respond? How do we catch up? Your sources show that just 1 week after Gagarin's flight, President John F. Kennedy sent a direct letter to his vice president, this was April 20th, 1961, asking pointedly how they could beat the Soviets. He specifically questioned, are we making the maximum effort? And he pushed for a space program that could, quote, produce dramatic results and give them a lead in the race.
And the answer he got was, well, audacious, almost beyond belief. For 1961. On May 25, 1961, in that famous speech, JFK promised the world that America would send humans to the moon and safely return them before the end of the decade. Think about that for a moment. No smartphones, no internet, no GPS, and computers that, filled entire rooms. It was an astonishing gamble.
Just incredible. And to achieve this monumental, nearly impossible goal, the U.S. poured an additional, $79 billion into the space program over the next 5 years. They effectively dedicated the entire space agency, NASA, to this single audacious objective.
So, okay, how do you even begin to build a program to send humans to the moon in less than a decade? It seems impossible. Your sources detail a rapid, intense, and, often painful series of tests.
Yeah, the initial efforts really focused on proving the fundamental components, developing powerful rockets just to get off Earth, designing heat shields tough enough for re-entry, which is a huge challenge, and perfecting propulsion systems for the service modules that would actually navigate in space.
And between 1963 and 1967, countless unmanned tests were carried out, pushing the limits of this brand new technology. But this breakneck pace, it came at a devastating cost. Just as the program was gearing up for its first manned test, Apollo 1 tragedy struck. January 1967, during a routine ground test, a cabin fire erupted, trapped and tragically killed all 3 astronauts: Gus Grissom, Ed White, Roger Chaffee.
A terrible searing blow. It really threatened to derail the entire moon mission before it even truly got off the ground. But remarkably, NASA persevered. After the Apollo 1 tragedy, they continued with crucial unmanned missions like Apollo 4, 5, and 6 for further rigorous testing.
Right. Then, in October 1968, Apollo 7 successfully sent humans into Earth's orbit. That proved the command and service modules were ready for crewed flight, a big step. Just 2 months later, December 1968, Apollo 8 took 3 astronauts all the way to lunar orbit, gave humanity its first breathtaking views of Earthrise. Iconic images.
Absolutely iconic. Then the crucial lunar module, the actual lander, that was put through its paces in March 1969 with Apollo 9 in Earth orbit. And then in May 1969, Apollo 10 practiced almost every single step the Apollo 11 mission would undertake. They went all the way to the moon.
Yeah.
Flew the LM down close, but stopped just short of the actual landing.
This relentless pace, a new mission practically every 2 to 3 months, it just underscores the sheer determination, the pressure to meet Kennedy's deadline. It all culminated on July 16, 1969, with the launch of Apollo 11. 3 astronauts were part of this historic mission. Commander Neil Armstrong, Command Module Pilot Michael Collins, and Lunar Module Pilot Edwin Buzz Aldrin. Now, Armstrong and Aldrin are household names, obviously, but you might be surprised to learn just how pivotal Michael Collins' role truly was.
That's a really important point. The Apollo 11 spacecraft, as your sources explain, had three main parts: the command module, the service module they flew together as the CSM, and then the lunar module, the lander. The plan was for the lunar module to detach, descend to the moon's surface, while the CSM, with Collins, remained in lunar orbit.
Exactly. So Michael Collins stayed in the command module, nicknamed Columbia, while Armstrong and Aldrin made their descent in the lunar module, nicknamed Eagle. This meant only Armstrong and Aldrin would actually get the chance to step on the moon.
But what's truly remarkable here, and often overlooked, is that while Collins didn't step on the moon, his role was arguably the most critical for their safe return. Think about it. The lunar module had to successfully rendezvous and reattach to the CSM for Armstrong and Aldrin to get home. Without Collins expertly piloting Columbia, maneuvering it perfectly in orbit, they would have been stranded.
Just stuck up there.
Exactly. It's an indispensable contribution, and perhaps, that's why he's not as widely celebrated, despite bearing just this enormous responsibility. The loneliest man in the universe, some called him.
So the mission began with that massive Saturn V rocket, a behemoth weighing 3 million kilograms, loaded with 1 million gallons of fuel. Just staggering numbers. It rocketed them into Earth's orbit in under 10 minutes. Incredible power. Then, after just 1.5 revolutions around the Earth, they got the go-ahead for translunar injection. That's the powerful engine burn that slingshotted them out of Earth's orbit and directly toward the moon.
Right, the big push. And the actual journey to the moon took several days. It was a period of anticipation, of just living in space, eating, sleeping, checking systems, and capturing those iconic images from the spacecraft windows. Then, on July 19th, 1969, after traveling almost 400,000 kilometers, Apollo 11 reached the moon's orbit and prepared to split into its two main parts, Columbia and Eagle.
And the tension, you could feel it building in the mission transcripts. As the lunar module began its descent, things started happening. Around 8:10 p.m., alarms blared, 12:01 and 12:02, program alarms. Neither Armstrong nor Aldrin knew what they meant. Imagine that moment. But from mission control, a calm voice, Steve Bales, I think, cut through, ignore it and keep going. Or rather, we're go on that alarm.
Yeah, just go. As your sources reveal, and we know now, these alarms signaled an overloaded guidance computer processing system. Too much data coming in. But thankfully, the computer was designed with a fail-safe. It prioritized essential mission-critical programs, ensuring they kept running despite the overload. This intelligent design basically prevented an abort right then and there.
Wow. So even with all that planning, you get these incredibly tense moments. And here's where it gets really interesting, according to your sources. At just 150 meters, maybe 500 feet from the surface, Armstrong looked down and saw they were heading straight for a boulder field. A crater littered with rocks, landing there. Disaster. He immediately took manual control, skillfully piloting the Eagle, flying it horizontally, looking for a safer spot, eventually finding one about 4 miles away from the original target.
Can you imagine the pressure in that moment, piloting this thing manually, low on fuel, with the world watching? Then, at 8:16 p.m., Buzz Aldrin checked the fuel gauge. A chilling discovery. Only 5% remaining. That's maybe 60 seconds of flight time left.
Mission Control on Earth immediately initiated a countdown for a potential mission abort. The clock was ticking down. Fast.
It truly came down to the absolute wire, with literally 30 seconds left in that abort countdown. Maybe even less. Some accounts say 20 seconds. Neil Armstrong's calm voice radioed back to Earth. Houston, Tranquility Base here. The Eagle has landed. It's just incredible. And what happened next was, well, etched into history. Watched by an estimated 650 million people worldwide. The largest television audience ever at that time. Neil Armstrong put on his bulky spacesuit, opened the hatch, carefully climbed down the ladder, and stepped onto the moon, delivering those immortal words. That's one small step for a man, one giant leap for mankind.
Buzz Aldrin followed him out soon after, and for the next, 2.5 hours they got to work. It wasn't just about planting a flag. They collected 23 kilograms, about 50 pounds, of moon dust and rocks, took countless photographs, set up various scientific instruments.
Right. While the Cold War was, the primary driver, this mission absolutely had significant scientific objectives. They set a television camera to transmit those grainy, unforgettable images back to Earth. a device to measure solar winds, the particles streaming from the sun, a laser beam reflector, which, by the way, scientists still use today to precisely measure the Earth-Moon distance down to the centimeter.
That's amazing.
It is. And they also deployed a passive seismometer, basically a super-sensitive microphone, to detect ground vibrations or moonquakes. This gave us the first clues about the moon's internal structure, telling us it wasn't completely dead geologically.
It really highlights how even a politically motivated, race-to-win endeavor can yield immense scientific benefits. They also left behind that American flag, of course, and a plaque attached to the LM's descent stage. It was inscribed, "Here, men from the planet Earth first set foot upon the moon. July 1969 AD. We came in peace for all mankind."
A powerful message. But the mission was far, far from over. The lunar module had to stay on the moon for about 21 hours before taking off again. They needed to rest, prepare for ascent, and time it right to rendezvous with Michael Collins in Columbia.
And speaking of unexpected challenges, your sources detail this moment that could have stranded them forever. It sounds like something out of a movie. Remember we mentioned Neil Armstrong brushing against something when he first got out? Well, later, preparing for liftoff. Buzz Aldrin discovered that the crucial ascent engine arming switch, the switch needed to ignite the engine to leave the moon, had been accidentally broken off. The little plastic toggle was gone.
Yeah, imagine that realization. They're suited up, ready to go home, and the start button is broken. They immediately informed Mission Control. Panic must have been setting in. But an ingenious, almost, kind of comical solution was devised. A switch basically just completes an electrical circuit, right? Aldrin realized that if the circuit was broken, something non-conductive on the outside, but maybe with the conductive tip, was needed to push the metal contact inside.
And what did he use? His felt tip pen, one of the standard issue pens they had. He simply wedged the tip of the pen into the hole where the switch should have been, pushed the contact, completed the circuit. And against all odds, the ascent engine ignited. It's just a testament to their cool heads and quick thinking under immense pressure.
Absolutely incredible improvisation. So, the lunar module successfully lifted off, leaving the descent stage behind and reattached to the CSM Columbia. The 3 astronauts were reunited and began their long journey back to Earth. However, the perils weren't quite over yet, not by a long shot. The plan for re-entry was for the service module, the big cylindrical part with the engine and supplies, to separate from the command module, the capsule, and burn up harmlessly in Earth's atmosphere. But there was a real danger its debris could collide with the command module during the fiery re-entry.
Right. NASA had actually installed small thrusters on the service module specifically to push it away safely after separation. But on the return journey, those thrusters failed to fire. They just didn't work. So the astronauts had to sit in the command module looking out the window and just watch, helpless, as the service module broke apart around them during re-entry, fiery chunks flying past. It was a terrifying gamble, really a miracle that none of the pieces hit their capsule.
The risk was considered so incredibly high. Your sources mention this, that U.S. President Nixon had even prepared an alternate speech. It was tucked away, ready to go, just in case. It read in part, "Fate has ordained that the men who went to the moon to explore in peace will stay on the moon to rest in peace. These brave men, Neil Armstrong and Edwin Aldrin, know that there is no hope for their recovery." Chilling stuff.
Thankfully, that speech was never needed. The command module Columbia descended safely through the atmosphere. Its parachutes billowed open, and it splashed down gently in the Pacific Ocean. All 3 astronauts were alive and safe. Mission accomplished.
Yeah, they faced problems at almost every single step, didn't they? But successfully dealt with them through ingenuity, training, and sheer resolve. And interestingly, upon their return, they were immediately put into quarantine for 2 weeks. This was due to the very remote theoretical risk of carrying unknown lunar pathogens, moon germs.
Right, the Andromeda strain scenario.
Exactly. Thankfully, nothing of the sort happened. They were perfectly healthy.
So Apollo 11's moon landing was massive global news. It fulfilled Kennedy's audacious promise from 8 years earlier. And for many, maybe most, it marked America decisively winning the space race. But for over 50 years now, this monumental achievement has also been a magnet for various theories suggesting it was all faked.
A hoax. Which raises that critical question, why do these theories persist? And what's the actual truth behind the common arguments? Your sources provide some very clear, straightforward answers to debunk these.
Okay, let's look at them. Your sources detail the most popular ones. For example, the argument about the American flag appearing to flutter in photos. The claim being, there's no air on the moon, so the flag shouldn't wave.
Right. And the simple reason is the flag was specifically designed for the lunar environment. It wasn't just a normal flag on a pole. It had a horizontal rod sewn into the top edge to keep it extended, precisely because NASA knew there was no wind. However, the astronauts didn't or couldn't fully extend that telescopic rod, so the fabric bunched up. This created natural ripples and waves in the fabric that made it look like it was fluttering in a breeze. It wasn't actually moving due to wind. Any slight movement you might see in video was just the aluminum pole settling after being planted, acting like a spring. Then it was still.
Okay, that makes sense. Another common theory suggests that stars aren't visible in any of the photos taken by Armstrong and Aldrin on the surface. The implication being it must have been filmed on Earth, maybe in a studio, against a black backdrop.
Again, this is easily explained by basic photography and the lighting conditions. The moon landing took place in broad lunar daylight. You had intense sunlight hitting the bright gray moon surface and the astronauts' highly reflective white spacesuits. Cameras back then, even the special Hasselblads they used, lacked the dynamic range to capture faint, distant stars against such incredibly bright foreground subjects. It's exactly like trying to take a picture of stars at night with your phone camera if there's a bright streetlight nearby or if your flash is on. The faint background gets washed out. You need long exposures for stars, and these were quick snapshots.
Got it. Then there are the arguments about shadows. People point to shadows in photos that aren't perfectly parallel, suggesting multiple light sources, like, Hollywood studio lights.
But the sun wasn't the only source of light on the moon. This is key. The moon's surface itself, the regolith, as your sources point out, is actually incredibly reflective. It scatters sunlight in all directions. Plus, you have light reflecting off the lunar module and even the astronaut suits. This diffused, scattered light, combined with the uneven lunar terrain, the bumps and craters created those seemingly bizarre or inconsistent shadow patterns. It's an optical effect perfectly consistent with a single strong light source, the sun, and a highly reflective, uneven surface, not multiple spotlights.
Okay, one last detail often brought up. There's that famous photo of Buzz Aldrin on the surface, and you can see Armstrong reflected in his visor. Armstrong appears to have a camera mounted on his chest, not held in his hand. So the question becomes, who took the picture of Armstrong himself descending the ladder for the first step?
Right, the who filmed the filmer argument. Your sources clarify this easily. The camera used to capture Armstrong's first steps, that iconic footage, was mounted on the outside of the lunar module in a special equipment bay. It wasn't held by anyone. Armstrong deployed it himself after getting out. And yes, the astronauts also had Hasselblad cameras mounted on their chests for taking still photos while walking around, which is what you see in Aldrin's visor reflection. So, multiple cameras, some fixed on the LM, some carried by the astronauts. No mystery third person needed.
All right, so those are some of the main hoax theories debunked. But beyond those, your sources also highlight that there was actual legitimate criticism of the Apollo program. Not everyone was cheering, even back in the 60s.
Indeed. And this is important context. As early as January 1962, the New York Times published an article pointing out that the estimated cost of the moon mission could build at least 120 Harvard-sized universities. This raised very valid, very important questions about resource allocation. Was this the best use of billions of dollars? Especially when America was facing huge domestic issues, widespread poverty, struggles with education, racial inequality, and increasingly the incredibly costly Vietnam War.
So given that enormous cost and those pressing domestic challenges, the real question then becomes, was it worth it? Was it ultimately a waste, as some critics claimed? Your sources argue pretty strongly that there were significant, often unforeseen benefits that arguably paid for the program many times over.
Yeah, what really stands out here, and something people maybe don't connect directly, is the profound impact on technology, specifically computer technology. Think about this. In 1962, the integrated circuit, the microchip, had only been invented 3 years prior. It was cutting-edge experimental tech. Even IBM, the computer giant back then, was hesitant to rely on these newfangled chips in their big mainframe computers. They preferred older, proven tech. But NASA, for the Apollo guidance computer, needed something small, lightweight, low power, and reliable. They needed integrated circuits. So NASA placed massive, unprecedented orders for these chips. They essentially created the first large-scale market for integrated circuits.
Wow. So NASA's demand didn't just, kickstart the industry.
It did more than kickstart it. This guaranteed demand drove the price of integrated circuits down drastically by over 90% in just 5 years, according to your sources.
90%.
Yeah. And crucially, NASA's reliance on these chips for human safety, for sending astronauts to the moon and bringing them back alive, it fundamentally validated the technology. It proved integrated circuits were reliable and capable. If computers using these chips could safely guide a mission to the moon, well, then they could certainly be trusted for business, industry, and eventually everyday life.
So that investment, as your sources underscore, didn't just push the boundaries of space exploration. It inadvertently created the essential market conditions and the vital public trust needed for the entire modern digital revolution. The computer chips and everything we use today have roots in that.
Absolutely. This massive investment in the Apollo program fueled exponential technological growth across the board. It wasn't just computer chips and software development, it spurred innovation in materials science, think fireproof fabrics, insulation, also in communications, medical imaging, even food processing with things like freeze-drying. It truly was a catalytic event for innovation, with countless spin-offs.
Okay, so despite its monumental success and those huge, unexpected technological benefits, Apollo 11 wasn't the start of, humans living on the moon or anything. In fact, the very last moon mission, Apollo 17, took place only 3 years later, in December 1972. And then for almost 50 years after that, nothing. No human went back to the moon. Why the abrupt end?
Well, it largely comes down to cost and shifting priorities. The Apollo program employed over 400,000 engineers, scientists, and technicians at its peak. It cost $24 billion back then, which is equivalent to well over $100 billion, maybe closer to $200 billion in today's money. That was simply an unsustainable level of spending, especially once the primary goal, beating the Soviets to the moon, had been achieved.
And public interest faded too, right?
Yeah.
By 1972, the moon landings weren't front-page news anymore. They became almost routine. Plus, as the Vietnam War dragged on and domestic problems mounted, the space program was increasingly seen by many taxpayers and politicians as an exorbitant luxury, a waste of money.
Exactly. Even though NASA had plans, detailed plans, for missions up to Apollo 20, including extended stays and more science, politicians had to heed public opinion and budget realities. The funding was dramatically cut, and Apollo 18, 19, and 20 were canceled. The Saturn V rockets built for them ended up as museum pieces.
A kind of bittersweet ending to that era. But now, half a century later, there's renewed global interest in returning to the moon, isn't there?
Yes, definitely. Your sources mention that in December 2017, former President Donald Trump signed a directive aiming to return astronauts to the moon, initially setting a goal for 2024, though the focus later somewhat shifted towards Mars as the ultimate goal.
But today, NASA's new Artemis program is actively planning a human return. Feels much more concrete now. They're starting with unmanned rocket tests, the SLS rocket and Orion capsule building towards crewed missions. And NASA has stated aims to land the first woman on the moon, possibly around 2025-2026, followed by the first person of color.
That seems to be the trajectory. China also has ambitious lunar plans, including crewed landings, India, Japan, private companies too. There's a new space race, arguably. So one thing seems pretty certain, based on all these current initiatives. We will see humans back on the moon, likely before the end of this decade.
So, wrapping this up, what does this all mean for you listening? This deep dive into Apollo 11 really shows us how these monumental achievements can arise from, unexpected origins like geopolitical rivalry, how they face incredible, life-threatening challenges at every turn, and how they can spark both widespread skepticism and doubt, but also profound, unforeseen progress that ripples through society for generations.
It really prompts us to ask, doesn't it? When you look back at such a pivotal moment in history, like Apollo 11, what truly stands out to you about that complex interplay between fierce global competition, audacious scientific ambition, human ingenuity under pressure, and the ever-shifting tides of public opinion and economic realities? It's a lot to consider.
We hope this deep dive into your sources has given you a fresh perspective on this truly iconic event, maybe going beyond the familiar headlines and the simple narratives we often hear.
Thank you for joining us on the deep dive.